Hello friends, welcome back. In previous tutorial we studied about page fault. Whenever there is a reference to a page which is not in main memory, the page fault occurs. And what happens after that? After that the required page is brought in main memory. But sometimes what happens that main memory is full. There is no free frame in main memory where we can keep the required page. So in that case what happens, one of the page in main memory is selected and that selected page is transferred from main memory to hard disk. In that case what happens, when the page is transferred from main memory to hard disk, the frame which was occupied by that page, it becomes free, and in that free frame we can keep the required page. So which of the page is to be selected to be transferred from main memory to hard disk? For that we have many page replacement algorithms. So in this tutorial we will study about FIFO page replacement algorithm. FIFO means first in first out, right? So in this tutorial we are going to study about first in first out page replacement algorithm. As I told you earlier that we have many page replacement algorithms. So how do we evaluate a page replacement algorithm? We evaluate a page replacement algorithm by running it on a particular string of memory references called reference string and computing the number of page faults. So we will run this FIFO algorithm also on a particular reference string, but first we will study about this FIFO algorithm, right? So what is this FIFO page replacement algorithm? In this algorithm what happens, the oldest page is chosen for replacement, right? In this algorithm the oldest page is chosen for replacement. So in this case what happens, with each page the time when that page was brought in memory is associated, right? So the page which is oldest, right, is replaced, right, whenever the page fault occurs and memory is full and we have to brought in a new page, right? So in that case we have to transfer a page from main memory to hard disk. So in a FIFO algorithm the oldest page is chosen to transfer from main memory to hard disk, right? The oldest page is chosen for replacement. So how we can implement this FIFO algorithm? So to implement this FIFO page replacement algorithm, a FIFO queue is created and it holds all pages in main memory, right? So whenever we have to replace a page, the page is replaced at the head of this FIFO queue, and whenever we have to bring a new page in main memory, the new page is inserted at the tail of the queue. Now let us see how this FIFO algorithm works. Now consider this reference string, right? This is the reference string. Now suppose we are having only 3 frames in main memory and initially these all 3 frames are free, right? So what happens, here you can see in a reference string the first reference is to page number 7, right? So initially all the 3 frames are free, right? So this page number 7 is not in main memory. So what happens, page fault will occur. So when page fault will occur, this page number 7 will be brought in main memory and it will keep in a frame. Now see this reference string, the next reference is to page number 0. Again the page number 0 is not in main memory, right? So again there will be a page fault and this page number 0 will bring in main memory, right? It will store in another frame, right? Now the next reference in see this in reference string, the next reference is to page number 1. Again the page number is 1 is not in main memory, so again there will be a page fault and this page number 1 will be brought in main memory and it will store in main memory in frame, right? Now see the next reference is to page number 2. Now page number 2 is not in main memory, so therefore there will be a page fault. Now here you can see that main memory is not free. All the three frames are occupied, right? In main memory there is no space for page number 2. So one of the page which is in main memory has to be replaced. Then which of the page should be replaced? There are three pages, 7, 0, 1. Page number 7, page number 0 and page number 1. Then which page among these three pages has to be replaced? So according to the Fifo algorithm, the oldest page has to be replaced. So here you can see in main memory there are three pages, page number 7, page number 0 and page number 1. Among these three pages, the page number 7 is the oldest page. So this page number 7 will be replaced, right? So this page number 7 will be replaced. So when the frame becomes free, in this frame which we will keep this page number 2, right? Now in main memory there are three pages, page number 2, page number 0 and page number 1. Now the next reference is to page number 0. Now you can see that page number 0 is in main memory, so there will be no page fault. Now see, the next reference is to page number 3, right? Now see, page number 3 is not in main memory, right? So we have to replace a page from main memory. So which page we will replace? Now here you can see that we have page number 2, page number 0 and page number 1 in main memory. The oldest page among them is page number 0. So page number 0 will be replaced, right? And we will bring in this page number 3 in main memory. After that there is a reference to page number 0. Again you can see that page number 0 is not in main memory, right? So again there will be a page fault, right? So when the page fault occurs, we have to bring in this page number 0 in main memory, but main memory is full, no free frame is here. So again we have to select a page for replacement. Then according to Fifo algorithm, we will select the oldest page. Now among these three pages, 2, 3, 1, the page number 1 is the oldest, so we will replace this page number 1 and we will bring in page number 0. Now the next reference is to page number 4, right? So here now in main memory we have the page number 2, page number 3, page number 0. We don't have this page number 4. So again there will be a page fault, right? Again there will be a page fault because the page which is referred, it is not in main memory, right? And here what we need to do, this page number 4 we have to bring in main memory, but main memory is not free, right? All the frames are occupied, so we need to replace a page. We have to select a page among these three pages, page number 2, page number 3 and page number 0. The oldest page among them is page number 2, so we will replace the page number 2 and we will bring in page number 4 in main memory. So in this way this Fifo page replacement algorithm works. Now actually it is expected that as the number of frames available increases, the number of page fault decreases. But this assumption is not always true. Some page replacement algorithms suffers from Bilady's anomaly. In them, page fault rate may increase as the number of allocated frames increases. For example, this Fifo algorithm. This Fifo page replacement algorithm, it suffers from Bilady's anomaly.